So neat. Hey, what's up, everybody? This is Papa Bale. Welcome. Currently got about 4 volts going into this beast. I got this green magnetic paper stuff. So neat, especially when it's moving, because it makes it carves out a pattern. So cool. I say that's pretty good for 4 volts, actually. There's less than 100 milliamps going in. So I don't know exact amp count because I don't have an amp meter, but it says 0 on my board. Yeah, we're going 200 and wow. 222 exactly. That's awesome. So that would mean that it was 666 because you divide by 3 because there's 3 magnets in there. 4 volts, basically 0 amps. And it's going about 250 now. Pretty sweet. Yes, sir. I was just looking at the pattern that it makes as you move it out away from the magnets. It gets a little less, it gets a little more translucent, a little less acute, and it kind of widens and spreads apart. I'd say it kind of plays along the lines of sacred geometry. The farther away you get from the center, the more complex and intricate the shapes and designs become. I think in the middle it's pretty simple. So I don't know, maybe there's something to that. I'm looking for a design for a counter-rotating motor that you can spin it like a top and it'll start spinning. You know, it'll work that way. I'll look into it. What is that exactly? A hallback assembly? Is it a permanent magnet assembly? See, because if I can like use the shaft as part of the device instead of like being more like a bike wheel, like over here, then you can spin it. You can get it started by twisting the shaft instead of having to spin it a different way, and therefore it will be more like a top or a dreidel, something like that. Just for a counter rotating pulse motor design. All right, I'm going to turn up the heat a little bit. We're going to put it, right now it's on 4 volts. We'll put it up to 7. Now, I was running this. All right, I do think I've heard of this before. I don't remember the design, but I thought it was pretty interesting. Absolutely, that'd be great. But as for this one, I had a single drive coil over here that was configured out of 20 gauge. It's lens wire. It's kind of wound up like a rodent coil wire. So it's got like 10 strands at 16 feet a piece, connected in 3 different series. It's interesting how I have it connected. I've got an AC connection through 3 strands, and then I put a diode in between the next 3, and then I put another diode in between those 3 and the next 4. So I have 3 separate coils in there that oscillate themselves, and then they get sent directly to the next one. But I think each one of these connections here that doesn't have a diode on it, there's a possibility for oscillation, most definitely. But the amps would continue to increase. I believe the coil got saturated way too fast. But the speed would increase as well. So it's not like it was totally useless amps. I got it up to about 2300, 2400 RPMs. And so I made a pickup coil for it. Well, I take down data. It might be useless data. I don't. It's not a project. Yes, yes, and yes. See, I've been doing this for 2 years, so it's not totally random, but it's not totally professional either. So yes and yes. I'm about to show you what's underneath here. So when I added the pickup coil, the amp draw went way down and stabilized at around 0.5. So I'm like, yay, that's good. That's more efficient than it continuing to increase without stopping. The 2400 is where I stopped it. Stopped increasing, letting it increase. But here's a trigger coil. So this sets the base of the NPN transistor. And it triggers the base. This coil right here is the main drive coil. It's got 10 strands of 20 gauge at 16 feet in length. So virtually it's 160 feet at 20 gauge, but it's hooked up intricately. I know we are far away from the center because of how I hooked this up, man. It is complicated as hell. Simple for me, but if you look at it, it's like, why'd you do that, man? Why the hell did you do that? I'm like, because it works well, and I had fun building it. So absolutely. 20 gauge. So you got a standard connection between like 3 wires in a coil. Like I do 3 connected, and then I put a diode in between the next 3, and then diode in between the next 3, which is actually 4 because there's 10 strands. So 3, 3, and 4. That's how it's all boiled out. But when I connected this one, see the amps continue to go up 1.1, 1.2, up to about, give or take 12, 13 watts of power into the system to make it go 2400. I added this coil, which is similar to that one, but it's only 6 strands at 16 feet. So it's a lot smaller. Its body is compact. So it's not like it's perfect for like a pickup coil. And I mean, at least what the description of a pickup coil is, smaller than the drive coil, and the same gauge would be good, especially if it's a drive system. With generating, I mess around with a lot of different gauges when I do the generation part, because some gauges produce more ampage than others do. It's all pretty low for the pulse motors, compared to others. But I mean, if all goes well, let me explain to you my grand design. I'd really like people to hear about that. For a pulse motor, that is. All right. So we might have 3 magnets on the rotor, okay? And then we'll have something like this on the bottom that will have drive. I believe we want 12 holes or 13 holes. It all depends. I think we might need, this is where I need to, talk to people about it. Does each phase need its own trigger coil? And I don't know the answer to that. But it's going to be like a 3-phase motor. It's actually going to be, let me just explain it. I don't know about the phases. I do know that it'll be a 120 degrees. So it'll be 120 4 times. So I guess 4 phases. It'll be off the trigger coil. And I want to have toggle switches for each phase. So like it'll run one phase efficiently. And then if I hit the switch, the second phase will automatically turn on. That's how I want it to be. And then you can run a single 2, 3, or 4 phase motor, and each phase will have 3 magnets that hit 3 coils. That is what I consider to be a phase. I might be, saying the wrong words or whatever, but that's what I think it is right there. And it'll be parallel. And I don't know, it's probably out there already. It would make sense if this motor was out there already. Like, really makes sense. But I'm going to build it. And I think it's going to be super duper spectacular. If I can get just like a teeny trigger coil, like shrink the size of my trigger coil and have it be just as effective as something like that, then I could put it in between. I could have a trigger for each one. And I think I'm going to need that. So I need to maybe do like 42 gauge or make them all 38 gauge, something like that. Something real sensitive so I can shrink the size a little bit. That'll be awesome. But this is just one coil of the design with a pickup coil, which I don't know if it'll be in the grand design or not, the pickup coil. I don't know if I'm going to need it. And I will draw a picture for everybody. So I'm kind of working on that right now. See, the benefit of having the switch here is that I can turn it all the way up to my desired voltage. And then when I turn it on, it's instantaneously that much voltage. It's just like plugging a battery directly into your system without any kind of modulation. In my mind, that kind of acts as a capacitor when you're trying to jumpstart your system or make it start by itself without using a capacitor. That's how I do it. I have the switch and I line it up so when I turn it on, it'll automatically start going. It's logical, nothing really special. It's just logical. Because I mean, when you turn it on using the power supply, you have a knob, right? So it's going to gradually go up. Even if you turn it all in one turn, it's going to work better with the switch. So at 9 volts in, okay, 9 volts in, we've got 0.1 amps, and it's fluctuating between 0 and 0.1. So it's less than 100 milliamps pretty much. Well, now it's stabling out at 0.1, so 100 milliamps. But yeah, that would be sweet. I'll definitely look into the Hallback spread, you know, how the array goes. I've done quite a few like permanent magnet, I call them boosters. It's like the motor is electric, but having these magnets in this position will aid, not hinder, you know, that kind of thing. I don't believe in fairy tales. So if you ask me if this is free energy, I'd tell you definitely no. I don't believe in that. This definitely has a cost. Even if you get like the numbers say more out than in, it doesn't matter. It has a cost. So I don't know. I mean, I believe that there's got to be some sort of like bridge being built now, so that like the way below and the way above and the people in the middle can all communicate with the same language and work together in a better way. I mean, I believe in a lot of things. Um, I believe that in solid state. Now, solid state is in my mind different because there's no kinetic energy involved in it. So it's not really a motor per se. It is definitely, but like I said, and I'm just getting into it a little bit. The solid states, like the Rodin coil, the Tesla coil, all the different style coils. Mm. So we're at zero point 0.3 amps, 9.25 volts. Let's get a tack reading on that. Wow, that was close. 3,300. So 1,100 RPMs right now. I'm recovering right now from, yes, you guessed it, some sort of food poisoning. Oh. All right. So what I'm getting at between just a standard drive coil without the pickup coil and with the pickup coil, at 9 volts, we'd be up around 0.7 amps, maybe 0.8. We're at 0.3 right now. So in order to get to where we want to go, we got to turn it up higher. Here, we'll do the 12-volt test. Um, this is with the pickup coil. Forty-two hundred and 4,300. That's divided by 3, okay? So you take the number that I give you and you divide by 3. I will do that when I get a chance. 44.8, oh, 44.8, 45.1. Jesus. 4,600. 0.5 amps. Okay, we're at 0.5 amps. 4767. 4791. 4800. 4900. You can get my kids some winter clothing today. We're gonna go shopping. It's gonna be great. Do that in about an hour from now. 5,000 divided by 3. We're going to go to the top end of 12 volts. So we're going to go 12.8, 9, 12.9 volts. 52. Wow, this is so fun. I didn't think that twisting the wire, like making it like rodent coil Litz wire, would make it better, but it is like way outperforming not twisting it, like by a long shot. 5,400. And now I'm going to turn it up to 15. We're drawing 0.6, 0.7 at 15.7, 58, 0.6 amps, 6,000, 6,100, 6,200. All right, we're not going to turn it up anymore, but that's pretty dang good. That's 2,100 RPMs at 15 volts and 0.7 amps. Wow, what a run. That's pretty awesome. All right, so now I'm going to remove the pickup coil, and we're going to do the test without it. Sound like a plan? We're going to compare the two. I should probably write that down in case I don't remember it. All right, so with so we got it to go 2100 RPMs with 15 volts and 0.7 amps. Probably would have gone a lot faster, but I had to do what was right, man. I just shut it down at 2100. It's not really the safest equipment. All right. So easy now, man. It's just like modular. I know where everything goes. It just flows. I'll write it down in case anybody wants to tag along, but kind of tell when these aren't clicking right. All right. So now it's just the trigger coil and the main drive coil. Kick it off at like 3 just to see if I did everything right. Looks good to me. But honestly, this is like a hobby for me. This is just something I do for fun. So, but it's not really random anymore. Random would be the wrong word. So 9 volts. Now the thing with just the coil like that is that the amps will continue to increase. At least they did thusly. So we're at 9.5 amps and wait a minute, no, 0.3 amps, 9.5 volts. And those amps will continue to go up, 0.4 amps. Point 0.5 amps. See, so we're at 9.5 volts. We're already at 0.5 amps with just the coil. So it's already less efficient in my mind because it's going to go above 0.5 amps now. Let's start taking the tach readings. Because there might be like an equilibrium somewhere where it's actually better the other way. But I know it's a very small range. Equilibrium is more like a point than it is a range. 35, 36. 12 volts in, 0.7 amps. Excuse me, 0.7 amps. 0.8 amps. 45, 46, 47, 4800, 49, 50. Wow, that's going up fast. 51, 0.8 amps, 0.8 amps, 12.2 volts, 0.8 amps. God, I sound like an auctioneer. 5,500, 0.8 amps. Excuse me, 0.8 amps. 58, 59, 0.9 amps. 61. I apologize. That was my insurance. I had to talk to them. That was real quick, though. I'm glad that was fast because sometimes those calls take a minute. And that is the negative side of using your phone to do your streaming. All right, let's turn that back on. Ha, what an interruption, man. What a great time for that. And it was all about a survey, too. Like, you don't need to call me for that. But yeah, it was about a call I made last night to them, and that gentleman hung up on me or went AWOL in the phone call. So yeah, but we got it taken care of. So neat, so neat. So we're at 0.9 amps, and we are currently at 12.8 volts. So I turned the voltage up a little bit. I don't know, man. I think it works kind of well with just the one coil. Heck yeah, man. That's awesome. 12.8 volts, 0.9 amps. 58, 5,800, 5,900. Wow. 6,000. Divided by 3, people. 6,000 divided by 3. So 2,000. $60, 2,100. Whew. That was just the rattling caused the transistor to fall. I gotta, you know what I'm gonna do is I'm gonna sweep this thing. I'm throwing it all in the trash. Anything that, you know, I'll test a few of them. Anything I don't want to hold on to is going in the garbage. I have tons of stuff that I can give away, and it isn't this stuff on the table. All right. So that is really, really neat. So I'm getting numbers. See, this little motor over here gets about the same numbers that this one does right now. With these coils, they're I don't know what it is, but somehow the cores like focus the energy like right where it needs to be, and this thing rips, dude. Like 3,000 RPMs. Yeah, I was. I don't even know what the hell happened, but I don't know. It's like I feel that brighter stuff is headed my way. Um, Not that it wasn't good; it was good, but I mean, still good. That's what I'm getting at. What am I talking about? Yeah. I don't know, man. People will be people, and that's cool. I don't mind that. I mean, yesterday I minded, but today I'm good. It's okay, man. I make mistakes, but you know, just keep it pulse motor related, and we'll all be good. 13.9 volts, 14 volts. Just gonna see if that'll work. And that right there is a testament to how powerful and well, like the magnets that are in there are so good for what's going on. So if you can't tell, that did take effect, and that will start to move faster. So yeah, I apologize sincerely for the interruption, but it was I had to be responsible about it. That was weird. So I like to make my trigger coils so that it only needs to pass once the magnet, and it needs to correspond to the strength of the magnet. So to make it that one pass work every time, it's got to be can't be too short, and the gauge can't be too thick. It's got to be a trigger coil, basically. What does that mean? 30, I would say the thickest you ever want a trigger coil to be is 26 gauge. That's the thickest. And then I'd say 30 gauge is pretty good. 32 gauge is good. And if you want to make it smaller, then you got to make the gauge, thinner. It's got to be a certain amount of turns. This one right here is, I believe it's 6,000 turns, 6,666 turns of 32 gauge. Check it out. Boom. Ha ha ha. You got to have kind of a hanged man perception. 1 amp, 14 volts, 63. Holy smoke. I bet if I clean this table off 100%, we could get it up to 3,000, 3,500. Because that rattling, like, it freaks me out. So, but if there's nothing to rattle, then no holds barred, man. We can go all the way. So, a prototype design of my top axial flux gyroscopic counter rotating pulse motor is kind of like this. All right, so you have your stator, which will be on the disc, right? You got your commutator underneath here. You can put your batteries on the disc too. Make it battery operated so you don't even need to tether it or use a commutator really. I mean, you still can, and you probably should to make the connections proper, but all the power will be coming from your disc, not from some other connection. So it will all be contained, and it'll all be, packaged at the, ready to sell at the store, basically. And then you'll get the counter rotating effect of a pulse motor, and this thing will probably go anywhere from 2,000 RPMs to 5,500 is what I'm guessing at like max speed. And if you build it right, if I build it right, whoever builds it, I don't care. But it takes the philosophy, the batteries, everything's on it already. Let me show you what I'm talking about. All right, so you got your coils, which will be a wedge-shaped axial flux formation. And then you got your batteries on the inner space, in between them. And then you put all your circuitry here in the third slot. And voila, you got a counter rotating pulse motor that doesn't need a connection to a power supply. It's already got it. Like this one right here. This one needs a connection to a power supply. But it'll spin with that connection because I made it so. I think that'll be sweet. And then the whole maglev will be contained within the shell that you build around it. So it'll be encased in the maglev. You'll have the maglev on the bottom. You'll have the shaft pointing, sticking out the bottom, right? You'll have your casing. You'll have the maglev in there. And then you'll have a maglev on it like it is right there. The big magnet. See, it's magleved. But that's how you maglev itself. You got to have a shell. It'll work. It's so work. And yeah, I think that's going to be awesome. I just, I was thinking about like an RC remote on-off toggle switch for it, just so it doesn't get like out of control. Because if it hits a certain rhythm, man, it's not going to stop increasing in speed. It will continue to increase in speed. But I don't know if that's, going to happen every time you turn it on. I don't know. I've never let it run past 2,100, 2,200, 2,300. Because as you see, like when it gets that high, everything on the table is like vibrating. So. All right. We're going to start it at 15. And I mean, there is a lot of things you can do, a lot of additions you can add to the breadboard to, add resistance and stuff. I have two resistors actually on the trigger coil, one in the positive, one in the negative, just because, just having the energy in there and coming out resisted on both ends it's good. It's good. It works a lot better with both of them than it did with just the one side having a resistor. So what I'm saying is, the ground wire has a resistor as well. That's what I'm saying. So we're at 15.5 volts, 0.3 amps so far. So what the pickup coil that I made for this particular motor aids in the reduction of current draw. So we're already at 0.7. I guarantee that with that coil hooked up, we won't get above 0.7. We're already at 0.8, 0.9. But like 0.7 is where it levels out at 15 volts. We're at 0.9 right now. One amp. So 15.5 watts. One 1.1 amp. 6100. 63. 65. 66. Woo-wee. Yeah, everything is vibrating. My feet are vibrating. That's awesome. That was awesome. All right. So that's like 2200. Wow. If you ask my opinion, axial flux is better, more efficient, and more fun to work with than radial. I like radial. I started with radial, and I think I'm going to end up with axial flux. And currently, I only work with DC. I mean, I need a way better way to administer the power than I do right now, which is virtually cutting off the end of a plug and plugging it in and having your two ends. That's virtually what I got for AC right now. And I'm not doing that. This is the extent of what I'll do with that. I plugged that into my DC, and now I have a knob to work with and everything. That's great. Yay, great. All right. Now there is like a transformer, AC transformer that I could buy. It's about $100 or so. That isn't going to happen anytime soon. But I do need one to start experimenting more with AC. Simple as that, really. Need to say a safer way to do it. So on the other end, on the flip side of all that, 2.5 volts in. 2.5 volts in. Give it a little whip, see if we can't get it going. I think that's good. That is definitely running. So neat. When I decided to turn it down below 5 and see if it would work, and it definitely does. So I got about 20, 30 more minutes, maybe 40. So if anybody wants to do anything that they, see here, more, somebody mentioned Hallbeck, Yuri mentioned Hallbeck. And I think that's a great idea. I mean, I got several experiments with other, no, that's okay. Not again. All right, I might have to take this if they call me back again. That really sucks. They must have a bunch of new people or something. Anyway, it is very close to the time that I'm going to have to go, about 30 more minutes. I will call them back. And turn it down even more. Let's go 1.5. We'll let it settle in. I'm not going to stop it and start it again because it'll be going too fast. It's already good. We're just going to let it settle in. If it's going to go, it'll go. Huh. 1.5 volts. I'm guaranteeing you it's less than a tenth of a 100 million. So it's like 10 milliamps maybe being drawn. Maybe 10, maybe less. If it goes at all. Should go because the trigger is firing the base, and 1.5 should be enough to make it move. I think it's working. I do. We'll see though. So I was thinking for the axial flux design, we used coils like this, like wedge-shaped coils, air coils. So It's really easy to tell which ways these are wrapped. Some are wrapped counterclockwise, some are wrapped clockwise. I want to lay them out in a pattern to so when it, yeah, I'll figure it out. It's going to be neat though. And these are really tight, really small. Ooh, are we going to keep going? I don't know, man. That looks kind of slow. That looks like it might stop. Ooh, is it going to stop? It's going to stop. That's definitely going to stop. We're going to let it stop though. Woo. Yeah, we call that good. Is that a good stop? That's a good stop. All right. Now we'll put it up to 2.05. See, if I would have stopped it and started it again, it would have be going faster than it was when I said it. So, yeah, I don't know. I think it was good. So I say 2 or 2.5 will probably be the best bet for its minimal range. And that is less than 100 milliamps by far, I'm pretty sure. So it's going to be less than a quarter watt, whatever is going on right now. So about 100 RPMs, which is nothing. That's really not cool, but for how much power it's taken, the fact that it's moving at all is pretty amazing in my mind. Because it's just a DC axial flux motor, and it is like running on 2 volts, nothing else really. Naturally, you're always going to have some kind of current. It's always going to be a wattage reading if it's moving, you know, or if there's any kind of like output, really. You're always going to have a wattage reading. I wish I had one of those little amp readers, man. I bet you it's like just 12 milliamps or something, maybe less. But I'm going to hook up the coil again. All right, so I hooked a diode up in between the main coil and the pickup coil. So that's a DC connection. And then every connection in this pickup coil will oscillate itself. So all these connections are AC, all the way to the power supply. So I don't know where you want to start, like 2.5. See if we can get it going at 2.5. I don't know if it'll go 2.5. I haven't like tried it. I think it will. 7, 8. $19.4 volts in. Wow, something must have came loose. Oh, that's what it is. Okay, sometimes I forget to flip the switch. So 19.4 volts. No amps yet. It's definitely working. I don't know how well it's working though. As soon as we start drawing some like milliamps, I'll be happy. Whoa, yeah, 100 milliamps. Put it up to 20.2. 0.3. About 20 more minutes. Let's see if we can get done in 20 minutes. 0.4 amps. 0.5. 0.6. 0.7. 4,300. 4,500. 47. 49. Woo! 40, 53. 6,000. Woo wee! Something went flying. Actually, I think it was drawn in. Something got sucked in. That's what it sounded like. So that got up to speed really, really fast. That was 20 volts in. So that was like 20 watts right there. Where's my pen at? I got to write this down. Oh, where did I put it? There it is. All right, without. 12 volts and 1 amp. So I gotta get my calculator. So as soon as I do my calculator, I'll get a final answer down here. But I tied it all together with the RPM. So, you know, at this voltage and amp draw, you get this RPMs with the coil and without the coil, pretty much. And it goes from like, say around 8.5 watts with the coil up to 12 watts without the coil. That's what I'm going to gather all the data is going to show. That reduces the amp draw a little bit. You got to put in a little bit more voltage to get the same amount of speed. But all in all, it's going to cost a little bit less to run with the pickup coil hooked up. Well, that's awesome. I'm glad that everything has been working out. Sometimes I do a stream and everything just doesn't work. So this is pretty cool. So I don't know, man. I mean, there's probably different magnet configuration for this one that I could do that'll make it go faster. Like maybe a 120 degrees instead of a 60 degree. But it runs. I mean, when I hook it up, it goes really, really fast. Just with just a reed switch. Like this one right here, it uses a trigger coil. I wonder if I could stuff a trigger coil in here, like right here. So it'd be right there, and just spin it, see what happens. I'll have to work on that one though. But yeah, when I get an impulse to do something, I pretty much go with it. And I've had an impulse to do a lot of this stuff. Pretty sure a lot of people are getting the same impulse to go out and do things that they enjoy to do. So I encourage you to go out and do that. Yeah, read up, do your research, all that if you feel you need to. If you don't know how to do the math, I don't necessarily consider that that you have to disengage. That is not what that means at all. Eventually, you will learn the math if you want to, if you need to. But it's weird, you know, the more I read, the more I found out that I already knew. It was like, wow, really? This is awesome. I'm like right in line with all of it. You know, even the mystical stuff, man. Even like, you know, sacred geometry. I don't know all the shapes and all the math involved with that, but I know its existence. And I know that in the center, it's simple. And the farther you expand from the center, the more complicated and intricate all the designs and shapes become, all the connections. And it's just a representation of, you know, the expansion of everything. It really does. The farther away you get from the truth, the harder it is to hold yourself together, so to say. But also, you come up with magnificent things like material that, the hotter it gets, it generates, energy with heat. It transfers heat into energy. You don't have that as a separate thing towards the center. It's more, the farther you get out, the more complicated and intricate the molecule designs become. Everything gets more and more complicated. But it doesn't necessarily mean that that's a bad thing in my mind. It just means that with more, knowledge, it keeps growing. It grows. That's what's happening. It's a growth pattern. In my mind, I try and figure it out. I mean, I don't read that much stuff, man. I don't, just show me a picture. I'll figure it out. I really don't. Yep, 10 minutes. Because, I mean, honestly, the stuff that I have on my shelf over here probably isn't going to match any of the stuff that I need to build this thing. I'm going to build it anyway because I know how it works. I know what it takes to make it run. And it might not be the safest, venture, honestly, but, as long I have faith in the force with this one. Literally, the force of inertia is going to force these magnets to go outward. There is no upward force. It's not going near fast enough to have an upward force. There's no fan blades or anything that's forcing it up. Okay, so there's no upward force. And then if it's going to flip out like this, and this is the only danger right here. There's no fire danger here. Okay, it gets hot, but there's no fire danger. I mean, if I walked out of the room like a dumbass, then there might be a fire danger, but that doesn't happen, like, ever. I never leave this thing unattended, and when I do, I freak out, man. So I learned my lesson. But yeah. So it's more like a bike wheel. You know what I'm saying? The axle is clamped down and the wheel spins on a bearing. That's how this one works. This one would be the opposite. The wheel is clamped to the shaft and the shaft spins with it. So it's more like a dreidel or a top. I really want to do this one, but I want to do it right the first time. Seriously, that would be so awesome to get it right the first time. Be so sweet. I might even use these coils that I've already built because I have PLA iron cores, so that might be interesting. So if anybody's been chatting, I really apologize. I don't see it popping up. It must have been when I reconnected from my phone call. If not, that's awesome. Thanks for hanging out, guys. I really appreciate it. About 8 minutes. What are we going to do in 8 minutes? See, I got this coil already. It's got an iron core, 18,000 turns of 32 gauge. But the weird thing about this axial flux motor is that there's not really enough torque to have an iron core. And I think that with the added speed from there being no core in any of the coils, makes up for not having the core by a long shot. Basically, what I'm saying is it won't work with a core. That's what I'm saying. I've tried it numerous times. I've tried gluing this thing down, so I've just tried it every which way you can do it. This motor will not allow you to use core. It won't work. I don't know why, but probably because it's low torque. Honestly, I believe it's pretty low torque. That's probably why I won't push past the iron core. It just bogs it down. It slows it down way too much, and then it ends up stopping. And besides, most of the axial flux motors that I've seen are coreless or air core. So that's where the way I'm going with this one. Now with this one, like I said, I'm going to use those wedge coils over there, and then they'll have core. So neat. Sir. So awesome. And basically, the way I see sacred geometry is the same way that the magnetic field functions. So I'll just turn this on low voltage. We'll get it going. You can see what I'm saying. Maybe you can see it. But you see how it's nice and dark and acute and opaque, and you can't really see through the magnetic field. It's all bright and stuff. You move it a little bit away and it starts to dissipate, but it gets wider, more complex, more convoluted, more diluted. You know, it's the same basic shapes, just like a sword, man, like folded over and over and over again, and expanded. So that it's kind of like that. That's how I view the sacred geometry aspect of the whole thing. The closer you get to the magnet itself, the more acute and opaque and everything is, more simplistic it is. And maybe we can do here. Let me. This will work. Got our cube magnet right here. So it gets wider and it dissipates. It gets more translucent. It gets convoluted. It gets diluted. It gets folded over and over and over again. The farther it gets away from its source. So that's awesome. I mean, I'll probably get into gathering more information on all of it. I mean, right now I'm pretty much just have my own idea of what it is. I seriously haven't read a lick. I haven't really watched any programs on it either. I heard about it, basically. And I'm developing my own opinions on it before I do any research, because that's how I do things. Three minutes. Oh. And there was this gentleman who asked very nicely, very politely, if I would stop posting. I told him no. And he said, you have to, because I asked nicely. And I said, no. And he had a name. And this is where I crossed the line. You know, I made fun of his name. I admit that, but it's like, yeah, I please and thank you. I asked nicely. Oh yeah, it was like, can you feel my face? And I was like, bro, if you stop snorting, then you can feel your own face. Again, I think I put an again in there. I don't know, man. It was a negative experience for me, but it's all good. I have a sense of humor kind of when I'm picking on people, but maybe that makes me a bad person. I don't know. I mean, the avatar's eyes were all red. I was going to make another joke, but I don't know, man. And I don't see a problem with me sharing my experiences. I mean, maybe I'm wrong about that. I mean, I'm not upset about any of the stuff that goes on, really. I just, I might appear to be, but I got my own problems that don't have anything to do with what's going on with this. Hmm. Very cool, though. I love this stuff. And yeah, I was just something. It's okay. You can politely ask me to do whatever you want. You don't have to politely ask because the intent will be there. I guarantee it. You're not going to be able to hide behind being kind. And besides, that's despicable. It's disgusting. You're going to lay me out. Lay me out, man. Don't, hey, buddy, what's up? That kind of BS. um, but he did ask nicely. I had to say no. He didn't like that. He called me the weakest link. Actually, this is what he said. He said, you need to view yourself as the weakest link. That's what he said. And I think that's funny, because, sometimes I do. Sometimes I view myself like, hey, man, you need to step it up another notch because you're falling below, you're in quicksand right now and you need to just, you need to get out of it. But hey, man, it's all good. Nothing but love. Gotta go. Thank you very much. Really appreciate you guys. Bye now.